Welcome to qnawire.
Hi, so for this question, what we're going to deal with is the reaction that corresponds to the dissolving of silver chloride in water. So first of all, I want you to think about this as an ice table directly, right? And this is going to be always in terms of concentrations because from here we're going to find the equilibrium constant. In this case, the value of Ka is not correct to say that this is the value of Ka. This would be the value for Ksp, right? Of the solubility product. So at the beginning, it doesn't matter the amount that we have because this is a solid, but the amount of change that is going to happen, the amount that is going to be dissolved, corresponds to S, the solubility for our compound. So that means that the amount of change that we're going to have for both of the ions is going to be plus S and plus S. So at equilibrium, we have S and S. This means that my solubility product constant, that is the concentration of silver plus times the concentration of Cl minus, is going to be equal to the solubility S squared. Now, what do we know about the solubility? We know that S corresponds that 0.48 milligrams are dissolved in 250 milliliters. So we need to convert this, first of all, in grams per liter. So 1000 milligrams corresponds to 1 gram. 1000 milliliters corresponds to 1 liter, right? So nothing has changed. Now I have 0.48 grams per liter, per 250 liters, right? Because 1000 and 1000 are going to cancel up, and the only thing that is going to change is the values that I have here. Now, grams of what? These are grams of AgCl. So we need to convert those grams into moles. Grams of AgCl divided by 250 liters. How do I convert grams to moles? Well, I need to divide by the molar mass. So 1 mole of AgCl corresponds to 143.32 grams. So, after doing this operation, what we're going to get is that the solubility of silver chloride is equal to 1.339 times 10 to the minus 5 molar. Great. So now we can use this information, this is the value for S, in order to get the value for Ksp. And Ksp is going to be equal to S squared. We simply need to take the square of that value, yielding 1.79 times 10 to the minus 10. And that is the answer for the first part of the question. Next up, we need to know what is the value of delta G naught at 25 degrees Celsius. So remember that 25 degrees Celsius is the standard state. We can use the equation that is delta G at any temperature is equal to delta G naught plus RT logarithm of the equilibrium constant. From here, since we are at equilibrium, delta G needs to be equal to 0, so delta G naught is going to be equal to minus RT logarithm of K. The value for R is going to be 8.314 joules per mole Kelvin. Remember that in this part, the temperature needs to be in Kelvin, so 25 degrees Celsius correspond to 298.15 Kelvin. So times 298.15 Kelvin times the logarithm of my K constant, logarithm of 1.79 times 10 to the minus 10. So delta G naught for our reaction is going to be 55,627.23 joules per mole, or, which is the same, 55.63 kilojoules per mole. Which makes sense because we know that the reaction is not spontaneous. The equilibrium constant, since this is an insoluble salt, is shifted towards the left of my equation, and the value for delta G supports this statement. And that would be all for this problem. Thank you very much.